We've already done problems like this one before, but I'm going to take a minute to review the idea and also give you a couple of pointers. If you want to find the sine inverse of 3/5, you can stick it in your calculator, but you'll just get a decimal approximation. If you then want to find the cosine of that angle, you're going to get the cosine of an approximation, which will itself be an approximation. In this particular problem, it turns out you could do it either way, and your calculator can tell you what the reduced form of the fraction would be, but it's not always going to be the case that that's easy to do. So let's walk through this problem the way that I expect you to do these on exams anyway, so that you'll know what to expect and what's expected of you. In this case, we have that the sine inverse is, the sine of an angle is 3/5. What is that angle? Well, we don't care about the angle. We do care about the angle. It's not that we don't care about the angle. The angle is some angle whose sine is 3/5. We don't need to know the value of the angle to answer the full problem. So if the sine inverse is 3/5, that tells me that there's an angle out there whose sine is 3/5. Well, sine is opposite over hypotenuse. So that means I'm going to have a 3 here and a 5 here. Well, this is very convenient because that makes this a 3, 4, 5 triangle. If you're not familiar with Pythagorean triples, you might want to look that up. 3, 4, 5 is a very common, very nice integer valued right triangle. So now that I have the three sides of the triangle, I can find the cosine of that angle. Remember that this right here represents an angle. It's the angle whose sine is 3/5. So if this is my theta, then now I want the cosine of theta. Well, cosine is just adjacent over hypotenuse. So my answer here is going to be 4/5. Now, if you type in cosine, it'll open a parentheses on your calculator, and then you type in second sine, it'll put this on your screen, and then you type in 3/5, close parentheses, and enter, you'll get 0.8 or 0.8. And if you reduce this to a fraction, you end up with 4/5. And that's great. So you can get the answer a couple of different ways, but this doesn't actually involve any trigonometry. It involves a bunch of button pushing, and I don't really care if you know how to push the right buttons on a calculator to get the right answer. I want to know that you understand the trigonometry. So if I ask you a question like this, I'm going to expect to see a triangle drawing and an indication of how you got this, how you got this other value, not just calculator work. It's fine to use your calculator to check your work as well, by the way, but I want to see you work it out this way. There's another way to do this problem. Your textbook outlines it pretty well. Let's just walk through what it is they did. Cosine of the sine inverse of 3/5. What if we take the sine inverse of 3/5 out and replace it with u? Let's just say u equals. Well, if u equals that, then I can replace it with u in the original problem as well. One way to write the cosine of u is as the square root of 1 minus the sine squared of u. That's one of those, a different form of the Pythagorean identity that we talked about earlier. And we said that u was a sine inverse of 3/5. So we can replace it. I can also write this is a step that's missing in your textbook, but it's just a notation thing. What this means is the sine of the sine inverse of 3/5 all squared. In other words, I could write sine squared of u as the sine of u squared, and that's what I've done here. This is the sine, use the wrong pen there. This is the sine of this thing squared, so I'm writing it as the sine of this thing all squared. Now, the sine of the sine inverse is just the argument, 3/5. And that's squared. So that becomes the square root of 1 minus 9/25 inside the square root. 1 can be thought of as 25/25, so 25/25 minus 9/25, and that's 16/25. 25ths. Let me adjust this a little bit. Don't need quite that much square root. And that reduces to 4/5. Now, I think this way is a little bit cumbersome, but it's another approach, and it's perfectly legitimate. Remember that we said u was the sine inverse of 3/5. So this is my answer. And it matches the answer that we got before, which is great. It just confirms that we got the right answer. As I said, I think it's a little bit cumbersome, but it also highlights something that we haven't used in a while. So it's not a bad thing to do that. The sine squared of an angle plus the cosine squared of an angle is equal to 1. If you subtract the sine squared from both sides, you get cosine squared equals 1 minus sine squared. And then if you take the square root of both sides, you get the cosine of an angle is the square root of, now I'm here, the cosine of an angle, this is my angle. Remember that this is an angle whose sine is 3/5, so this is an angle. The cosine of an angle is the square root of 1 minus the sine squared of that same angle. We let this be equal to u. So that just confirms that identity, and I use it a different way. I still prefer the triangle method. It's a lot cleaner and it's pretty straightforward. There's nothing wrong with this method, but it's just a different approach. Now I'd like to do one more of these. In this problem, we took the cosine of the arc sine. In the next problem, I want to take the arc, maybe the arc cosine of the sine, for example. Another way to write this is cosine inverse of the sine of 5 pi over 4. Your choice, but it's not always your choice the way it's written and presented to you, so you should be comfortable with both of these formats. They mean exactly the same thing. Now in this problem, I'm going to be taking the sine of an angle first and then finding the inverse cosine of that angle. Now I can see that this angle is bigger than pi. 4 pi over 5. 4 pi over 4 would be pi. So I'm going to make a little set of axes here. Let's see, this would be 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. That's a 45-degree angle from the x-axis, from the negative x-axis. So my angle is 5 pi over 4, but my reference angle is pi over 4. I want to take the sine of that angle. Specifically, I want to take the sine of this angle, this big angle here, that's 5 pi over 4, but I'll get the same answer as long as I consider the sines, SIGN, of taking the sine of this angle. Now, the sine of pi over 4 is the square root of 2, opposite, over hypotenuse, 2. The square root of 2 over 2. My hypotenuse here is a radius. Remember, we labeled these sides x, y, and r. My radius is always positive, but my dropped vertical here is actually negative the square root of 2 because it's below the x-axis. To get to this point right here, I had to go some negative distance in the x direction and then down the square root of 2. And I don't know what this is yet, although I could find it easily enough just using the Pythagorean theorem. But what matters at the moment is the fact that this is a negative stretch of distance, right? It's down from the x-axis. It's a negative coordinate. So that's a negative value. So I'm going to erase my alternative version of the problem here. And then let's write this as arc cosine of the answer to this part of the problem. The answer to what is the sine of 5 pi over 4 is negative the square root of 2 over 2. Right? We have 5 pi over 4 is this big angle here. Let me write it in. Let's do it in pink. This is 5 pi over 4. But to find the cosine of that angle, to find the sine of that angle, I just need to find the sine of the reference angle and make sure my sines, SIGN, are correct. All right, so I've done that. I found the sine of 5 pi over 4. It's negative root 2 over 2. And now I need to find the angle whose cosine is negative root 2 over 2. Well, let's remind ourselves where cosine is positive, first of all. Let's see, I'll put it here. Cosine is positive in quadrants 1 and 4. And we are looking for our cosine, the angle whose cosine is this value. Our cosine is this value, and our cosine is negative. So we want to take our angle from one of these two quadrants. Fortunately, we're already in one of those two quadrants, but unfortunately, arc cosine, well, we're only allowed to play with arc cosine, or the inverse cosine, in these two quadrants. Now, my criteria have to be met. Both of my criteria have to be met. The cosine of my angle has to be negative, which means I must be in one of these two quadrants, and I'm working with arc cosine or inverse cosine, which means I must be in these two quadrants. The only place they overlap is in quadrant 2. So now what I need to do is find a reference angle the same size as this one in quadrant 2, and my cosine will still be negative, but I'll be in the allowable area. So what is the reference angle that matches the size of this one that's in quadrant 2? Well, the reference angle is still pi over 4. So let's draw that in. So we're looking at this angle right here. This is pi over 4. But now I'm in quadrant 2, where I'm allowed to play with our cosine, and my cosine is still negative. Now it's the same size of triangle, so the lengths of my sides are going to be the same, or at least the ratios are going to be the same. So I have a positive square root of 2 here and a 2 for my radius, or my hypotenuse. Now the cosine is adjacent over hypotenuse, and that means this is going to need to be negative as well, but it is because of where it is on the x-axis. In fact, that's why we can only work with these two quadrants if we want our cosine value to be negative. This is our cosine value. We need to find out what the angle is that gives us that cosine value. Well, we kind of already know, right? There's pi over 4. We decided we needed the same size of reference angle as we did in quadrant 3, but in quadrant 2. So now the reference angle is pi over 4, but the angle I'm looking for is this one right here. That's the angle that satisfies this question. And that angle is 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4. So the answer to this question is 3 pi over 4. These problems all require some thought. Could you type this into your calculator? Absolutely. Would it give you the right answer? Yes, to a point. You were asked to find the exact value, and your calculator would only be able to give you a decimal approximation. Even so, I'm much more interested in whether you understand the trigonometry than whether you can punch buttons on a calculator. So that's actually one of the reasons for asking you for the exact value. It sort of forces you to show me that you can do the trigonometry and not just use your calculator. Fortunately, this is it for this topic, and it's also the end of the section. Not only that, it's the end of the unit. So when you're done with this video and the homework that goes with it, you'll be taking a quiz and then an exam. Good luck on those, and do let me know what I can do to help.